Welcome to the channel Raj the Physicist, one of the finest platform to learn the concepts of physics. This is a part 1 in the lecture series on the topic that is waves. So we will understand about what is meant by a wave, what are different types of wave and what are the fundamentals of wave in this session. So firstly we need to understand what is meant by a wave. Wave is a kind of disturbance that is produced in a medium and it can transfer the energy from one point to another point. You can see there the definition of a wave, and now we will look a very interesting example of a wave. That let's suppose that we are having a rope that is attached to a wall and I am going to produce some kind of disturbance over here. Then what will happen? Let's see that. So I am producing some kind of a disturbance. That disturbance is going to travel from one location to the other location. That is, it is going to start at this position and it is going to end at the last part, that is end of the rope attached to the wall. So what exactly going to happen here, that I have shown in this diagram. So you can see here, as I produced some disturbance along y-axis, that is along vertical direction, then after some time period, after certain time, the position of the disturbance has changed and it has finally reached to the end position. That means how this transfer of this disturbance is going to take place. Now you can see one thing over here is, initially all the particles of the rope are in equilibrium position. That means they are not going to have any kind of disturbance. Now when we are applying certain force, that we are generating some kind of a disturbance, due to that the particles are now getting some kind of vibration. They are going to oscillate in vertical direction. That means they are going to oscillate along vertical direction and the disturbance is going to travel along the x-axis direction. And one more important thing here is that this disturbance, if we observe, let's suppose that we are observing the particle position over here. So initially when we are producing some disturbance, the particle's position 1, let's suppose this is particle 1, so that is P1 I am going to write. After a certain time the position of the P1 is going to come to the equilibrium position, that is now the position of the particle is over here. And some particle, let's suppose here the particle P2 is going to have some disturbance, that means it is going to have some amplitude or it will have some displacement. That means here particle P2 will going to have some displacement, and then again after certain time the particle P2 again reaches to the position, that is equilibrium position. And here some particle, other particle, let's suppose this is particle P3, is now having some maximum amplitude. Again this particle P3 now reaches to the equilibrium position after certain time, and finally we are getting the disturbance that is traveling from this position to the final position. So this is overall thing will happen in case of a simple example, that is rope attached to a wall. One more important thing we need to know here is the particles are going to only oscillate to and fro, and the disturbance is going to travel from one point to other point. As we have seen over here, the particle position P1 remains here in the equilibrium position. If it is in maximum displacement, then it is at this location. That means particle P1 is not traveling from this location to this location, right? Similarly particle P2 also can have two positions, either this position or this position. That means it is going to have the to and fro motion which is shown over here, and particle P3 also will not going to travel from this position to this end, because the particle can only oscillate. It is the disturbance that is going to travel. Okay, I hope that you have understood this particular point. It is a very important point because particles will only going to oscillate, particles will not going to travel. The traveling is going to be, the disturbance is going to travel from one point to other point. This disturbance will carry some energy. So that energy is going to be dependent how much the disturbance we are producing. So this is the first part that we have understood. Now we are going to understand about the fundamentals of wave. For that I need some space over here. Now let us see what are the types of waves and what are the fundamentals of wave. First thing that we need to know over here is what are the types of waves. So first thing is about there are two types of waves, mechanical waves and non-mechanical waves. And mechanical waves can be categorized into two parts, that is transverse wave and longitudinal waves. Okay. And non-mechanical waves, we will see about this particular thing. Firstly, what are the mechanical waves? Mechanical waves require certain medium to propagate. So mechanical waves require some medium to travel or to propagate, whereas non-mechanical waves do not require any medium to propagate. Now we will learn about what are the transverse waves and what are the longitudinal waves. If the vibrations of the particles are along y direction and the wave is going to get generated along the x axis, then we can call this type of wave as transverse wave. Okay, just now we have seen the example of the rope. This can also be used in case of, for example, if we are taking the example of guitar, stretched string. So in this we can have the production or the transverse waves can be produced in case of guitar and in case of stretched string. And coming to the longitudinal waves are the waves in which the disturbance of the particles, that means the vibrations of the particles, are going to take place along x-axis, that is parallel to the direction of propagation of wave. First thing, once again, the vibrations of the particles are going to happen in case of transverse waves that are perpendicular to the direction of propagation of wave. And here in this case, in case of longitudinal waves, the vibrations of the particles or oscillation of the particles are going to take place in a direction parallel to the direction of propagation of the wave. That means here one thing you have to remember, if we are having the vibrations which are along y-axis, that means perpendicular to the axis of propagation, so that those waves are called as transverse waves. And if the direction of the particles vibration and the direction of the propagation of wave are parallel to each other, then those waves are called as longitudinal waves. So this is about the transverse waves and longitudinal waves. Now we are going to learn about what are the fundamentals of waves. Now let us see the fundamentals of a wave. A wave can be characterized by a few things. The wave will have few things. Those things I am going to write first over here, and in detail we will see about each and everything. The wave can be characterized by, let's suppose that I am just writing first an equation of a wave. y is equals to a sine of omega t minus kx. Okay, and also I will going to write here plus phi. So this is a general wave equation, I mean general solution for a wave equation, not the general wave equation. The general wave equation can be written by this: dou square y divided by dou t square equals to 1 by v square into dou square y by dou x square. So this is a general equation of a wave, and this is the solution for this equation. First thing that we need to know, what is this general solution, and in that what are the fundamental waves that we have. So first thing here I am going to just rub this part. Later on we are going to learn each and everything in brief, but right now we need to know what are the fundamentals of a wave. So the wave can be characterized by, first thing that is, y here is amplitude of the wave, and here y is the displacement of the wave. A represents amplitude, omega represents the angular frequency, k represents here the propagation constant, and also a few things. Phi is the phase, that may be the initial phase of the wave, and also we will write here a few things such as lambda represents the wavelength and nu represents the frequency. So first thing that we need to know here is, we have written y is equals to a sine of omega t minus kx plus phi. This is the general solution for a wave equation, where y represents the displacement, a represents amplitude, omega is the angular frequency, k is the propagation constant, phi is the phase, lambda is the wavelength, and nu is the frequency. There are few things that we need to know here. What is this amplitude? Amplitude is the maximum displacement that the wave can have. Amplitude represents the maximum displacement the wave can have. For example, if we are going to draw a wave over here, then this will be the maximum displacement from the mean position. So that represents the amplitude. And if we are writing this as one cycle, one complete cycle, then the distance of this cycle will be total here 2 pi. So here it will be 0, next here it will be pi, and here it will be 2 pi. Here we can write pi by 2, here 3 pi by 2, that means over here. So a wave, for a complete wave cycle, we can write one thing over here, that is the distance between two consecutive points. Okay, the distance between two consecutive points which are having the same phase is known as wavelength. Okay, frequency we can generally write, already I think you know, frequency can be written as number of cycles per second. So number of cycle per second can represent the, or actually number of cycles we can write, number of oscillations also we can write, oscillation per second gives you the frequency. Simply we can write nu is equals to 1 over t. Okay, and also propagation constant, that is in 2 pi, this from 0 to 2 pi cycle, how much is the distance that is traveled. K can be written as here 2 pi divided by the total distance from here to here is one wavelength, that is, so we can write k is equals to 2 pi by lambda, and here omega represents the angular frequency. Angular frequency formula we can write omega equals to 2 pi divided by t. Also we can write here nu is equals to, if we substitute 1 divided by t, for 1 by t we can write omega equals to here 2 pi into nu. So these are all the basic things about a wave. So I hope that this will help you to understand what is a wave, what are the different types of wave, and what are the fundamentals of a wave. So that is all for today. Thank you so much for your time.